Okay, ito yung ASCII 97 Fundamentals IP Edition or English Units. Ito nga Table 1A. Ito yung 99.6 and 99% for heating to sa wind design conditions. So magamit ko lang wind design to sa mga wind turbine, di ba? Ano yung wind speed, standard pressure. Yan. Okay. The next is table 1B. Cooling, sa cooling to, and the modifications. Dito yung babanggitin natin mamaya, 0.4%, 1%, 2%, cooling, dry valves. So, ito yung design value mo, kukunin mo dito, isa dito, mamaya sabihin natin, sa 2% na kaya. Okay? Hindi tayo babalik dito kasi papagod. Tagtatagalan tayo. So, yan. Ito yung ginamit natin. Example is, yan na. Ito. Yung ginamit natin. Ang value, yung range, 19.8, 90 and 75 kasi 2% tayo. So, itong ginamit natin. Design value. So, next, table 1, table 2A. Tingnan natin ano yung table 2A. Table 2A is for Canada. Same sa table 2B. Yan. Ang B is cooling and the humidification design. Sa C, sa table 3A, world location. Andito yung, hanapin mo yung Philippines. Gusto mo ng mano-mano. Kasi required sa mano pag nag-PEB ka, mano-mano kailangan. May iba required mano-mano, may iba computer. Super. Philippines, nasan ka na? So, Japan. Kazakhstan. Ayan, Philippines. So, merong Angeles, Baguio, Cebu, Manila. Manila ang ginagamit natin is 14.5% na latitude. Tandaan nyo, example natin is 40. Ang sa table doon, naka-table is yung sa CLTD table is 40 degrees. So, meron daw mga correction factor para sa 14.5, 52 degrees. So, dito rin yung yeah. Heating to heating. Ito yung calling Philippines. Heating sa Baguio. Okay? Dati normally is heating na. Ayan ang Philippines. Okay? Yung north latitude, longitude, andun sa table 3A. Dito na yung yan, ito yung design condition natin sa 2% nga. Bawa, Philippines is 93, ang Manila 92.79. Yan. So sa atin, ginagamit ko is yung 95.81 or 82. Ito. Ito yung peak natin. So kung gusto mong conservative, is dito ka sa 92.79. Sabihin, ang pinaka-peak percentage na is, segment ko itong muna, is 0.4%. Pero hindi naman yun madalas. Diba? Kasi minsan lang. So dito tayo sa 2% sa iba din design. 2%. Mamaya ma-explain natin yan. doon sa lecture. So, ginagamit ko is ito, 9582. Gusto mo lang, kasi may mga kliyente kasi na, ba't itong oras, maski saglit, isang araw, sure naman na may. Okay. Design condition lang to, typical. So, kung gusto mong ma-measure sa actual, so measurein mo. Pag tumaas, pwede siya maging 100, 97, 98 sa actual conditions. Depende sa iyo kung saan mo i-design. Pero wala kang data ito. So, baba ito. Sa Philippines, ito yung dinidesign natin. Sa example natin, gamit natin ito. May mga batas kasi sa ibang bansa na ginagamit kung anong gusto yung gagamitin dito. Yan. Okay. The information provided in table 1B, 2B, and 3B are for cooling and humidity control conditions that include, yun nga yung pinakita kanina ng mga table B, A, dry bulb temperature corresponding to 0.4, 1%, 2% annual cumulative frequency of occurrence, and the mean coincident wet bulb temperature, warm. These conditions appear in sets of dry bulb, dB, temperature, and the mean coincident wet bulb, MWB, temperature, since both values are needed to determine the sensible and latent or the humidification loads in the cooling mode. Also, letter B, wet bulb temperature corresponding to 0.4, 1%, and 2% annual cumulative frequency of occurrence in the mean coincident dry bulb temperature. Letter C, dew point temperature corresponding to 0.4%, 1%, and 2% annual cumulative frequency of occurrence, and the mean coincident dry bulb temperature and humidity ratio calculated for the dew point temperature at the standard pressure at the elevation of the station. The main daily range, DR, of the dry bulb temperature, which is the mean of temperature difference between daily maximum and minimum temperature for the warmest month, highest average dry bulb temperature. These are used to correct the CLTD values. Now, in choosing the HVAC outdoor design conditions, it is neither economical nor practical to equip to design equipment either for the annual hottest temperature or annual minimum temperature. Yung sabi kayo na 0.4%. Na? So, ginagamit sa iba is 2%. Sa atin, si hottest tayo. Economically, since the peak or lowest temperature may occur only for a few hours over the span of several years. Economically speaking, short duration peaks above the system capacity might be tolerated at significant reduction in first cost. This is a simple benefit decision for its building design. Therefore, as a practice, the design temperature and humidity conditions are based on frequency of occurrence. The summer design conditions have been presented for annual percentile values of 0.4, 1, and 2%, and winter months conditions are based on annual percentiles of 99.6 and 99%. The term design conditions refer to the percentage of time in a year. It's 60 hours. The value of dry bulb, dew point, and wet bulb temperature exceed by the indicated percentage. 0.4%, 1%, 2%, and 5% values are exceeded on average by 35, 88, 47, and 48 hours. Yun yung oras ng 4%, 1%, and 58 sa 8760. So the 99% and 99.6% code values sa heating undefined in the same way but are good as the values for which corresponding weather elements are less than the design condition of 88 and 95 hours, respectively. 99.6% value suggests that the outdoor temperature is equal to or lower than the design data 0.4% of the time. Design condition is used to calculate maximum heat gain and maximum heat loss of the building. For comfort cooling, use of 2.5% occurrence and for heating, use of 99% values is recommended. Since sa table sa ASRE is 2% ang available dun. So 2% ka. Okay. It is the 2.5% design condition means that the outside design summer temperature and coincident air moisture content will be exceeded only 2.5% of hours from June to September or 75th out of 2928 hours of this month. That is 2.5% of the time in a year. The outdoor air temperature will be above the design condition. Note in the energy use calculation, hour by hour outdoor climate data of a design day should be adapted instead of summer and winter design values. Per hour. So indoor design conditions and thermal comfort. Tignan tayo sa inside. The indoor design conditions are directly related to human comfort. Current comfort standards as the standard 55-1992 and ISO standard 7780 specify a comfort zone. Huwag ka basta-basta ano ng ganito yung temperature kailangan kasi ang ginamit natin sa dating room. Pero iba palang room yun. Representing the optimal range and combination of thermal factors, air temperature, radiant temperature, and velocity, humidity, and personal factors, floating activity level, with which at least 80% of the building occupants are expected to express satisfaction. The environmental factors that affect the thermal comfort of the occupants in the air-conditioned space are mainly A. Metabolic rate. Dalaw mo. Express and MET. Or 1 MET is 18.46 BTU per hour square foot. Determines the amount of heat that must be released from the human body, and it depends mainly on the intensity of physical activities. Then B, indoor air temperature, T sub R, and the mean radiant temperature, T sub R, both in degrees Fahrenheit or Celsius, equal to SI. They are affect the sensible heat exchange and the evaporative losses, and T rad affects only sensible heat exchange. Letter C. And D, air velocity of the indoor air in feet per minute, which affect the heat transfer coefficient, and therefore the sensible heat exchange and evaporative loss. Later, makita natin yung pagkuha ng U value. Tapos yung film coefficient doon, based yun sa still air, tawag yung still air, yung air doon sa loob. Meron siyang still air, pero meron siyang speed pa rin ng konti. So talagang lumilipad na hangin. Okay. A, clothing insulation in CLAW, clothing units. 1 CLAW is 0.88 hours per square feet Fahrenheit per BTU. Affects the sensible heat loss. Clothing insulation for occupant is typically 0.6 CLAW in summer and 0.8 to 1.2 CLAW in winter. Diba? Pag wala kang damit, 0 CLAW. Zero ba yun? Basta ganun. 1 pala 1. Sabihin, pag may damit ka, makapal, so bumababa yun. Ano yan? Resistance pala yan. Tama, resistance. Mataas yung resistance mo. Okay? Check natin mamaya sa clothing insulation. Kung naka-jacket ka, siyempre, hindi masyadong marapigan. So, for comfort air conditioning system, according to ANSI ASHRAE Standard 55-1992 and ASHRAE IES Standard 90.1 to 1989, the following indoor design temperatures and air velocities apply for conditioned spaces where the occupant activity level is 1.2 MET. Indoor space relative humidity is 50% in summer only, and TR is equal to T rad. Nandito yung table. Protect insulation sa winter and summer. So, summer, 0.5 to 0.6. Typical. Indoor is 73 to 79 Fahrenheit. Typical. Convert yan lang sa DBC, ha? So, this is air velocity less than 50 feet per minute. So, if a suit jacket is the clothing during summer for occupant, the summer indoor design temperature should be dropped to 74 to 75 Fahrenheit. Yeah. The recommended indoor relative humidity and percentage is the summer, tolerable range is 30 to 65, preferred range is 40 to 55. Nagamit ko tayo ng 50% ang ginagamit natin, 50 to 55. Diba? Pag 40, masyado na malaki yung aircon. The Psychrometric chapter of the Fundamentals Handbook, Chapter 6, 2001, also 1997, parang din to, provides more details in this aspect. The load calculations are usually based on 75 Fahrenheit live bulb temperatures and 50% relative humidity. Usually. Pero pag meron kang mga room conditions na room classification, so depende na sa sa design. Indoor air quality and outdoor air requirements. So according to the National Institute for Occupational Safety and Health, NIOSH, 1989, involved na yung health changes sa ventilation yun. May IAQ, puso nga niya sa mga sa nagka-COVID, di ba? There are three basic the causes of indoor air quality complaints in buildings are inadequate outdoor ventilation air. Yung iba, natin yung mga free blow, hindi yan masyado effective kasi recirculating lang yan. Pag binuksan mo yung pinto, buksan mo bintana, abang mandan yan, nag-circulate yung hangin dyan sa magiging effective. Yung indoor air quality. Diba? Kasi napapalitan yung maduming yung room air. So, there are three, yung iba, nilalagyan ng fresh air. Yung mga kanyang ano siya, free blow. Hindi na siya free blow. Meron siyang fresh air tapos may exhaust. Ito talaga ang normal na air conditioning. And at three basic means of providing indoor air quality. One, eliminate or reduce the source of air pollution. Enhance the efficiency of air filtration. And three, increase the ventilation outdoor air intake. Hindi mo nang pwedeng 100% outdoor. Masyado malaki. Meron mga minimum allowed dyan. Okay? So, for example, ordinary office, mababa yan kaysa doon sa salon. Barbershop, sa salon, spa, malaki yung ventilation air mo dyan. Okay? A bridge outdoor air requirement listed in ASRE, ANSI ASRE Standard 62-1989 are as follows. Available tools, pwede ito ma-download. Hindi ko na kayo bigyan, ma-download yun na lang. Pero yung table ng mga ventilation rate. Later sa topic nating indoor air quality dito sa subject. Lalabas yan. Application. Andito application mo. Offices, CFM conference room, offices. Andito yung CFM per person is 20. Actually, mataas nga to. Retail offices, 0.2 to 0.3. Classroom, theaters, auditorium, 15. Hospital, patient room, 25. So, check yung latest niya. Medyo mataas ng 20. So these ventilation requirements are based on analysis of dilution of CO2 as the representative human bioeffluent. So kaya pala sabi ko mataas kasi doon sa software, 7, that is 5. 5 lang to. Bagay, ano pa to? 1989. Okay, meron dito 1990s na. 2000 plus. Okay? So as per ASTRA standard 62-1999, comfort criteria with respect to human bioeffluents is likely to be satisfied if the indoor carbon dioxide concentration remain within 700 ppm above the outdoor air carbon dioxide concentration. So other topics daw. Ng ppm sa environmental engineering yun, dapat alam niyo yung mga ppm, carbon dioxide concentration, that is main involved doon sa environmental engineering, pollution control. So, yeah. Refer to ANSI as the standard CC2 plus 1999 for details. Next, building pressurization. So, normally, ginagamit ito sa clean rooms, mga pharmaceuticals, hospital din ginagamit din. Pero sa commercial, residential, hindi masyado ito. Meron din siyang pressure pero di namin i-measure. So the outdoor air requirements are sometimes governed by the building pressurization needs. Most air conditioning systems are designed to maintain a slightly higher pressure than the surroundings. Automatic na yun kasi pag nag-under ng aircon mo, may pressurize na. A positive pressure to prevent or reduce infiltration and untreated air entering the space directly. For laboratories, restroom, or workshop where toxic hazardous or objectionable gases or contaminants are produced, a slightly lower pressure than the surroundings. A negative pressure should be maintained to prevent or reduce the diffusion of this contaminants to the surrounding area. So, para maging negative, gagawin mo siya na wala kang supply kundi exhaust lang. Kumbaga, ang meron kang supply dito is yung mga infiltration lang, hugot lang. Hugutin mo sa ibang room tapos i-exhaust mo. Hindi siya makakapunta sa ibang room. Okay? CR. Hindi pwedeng maging pressurized at papunta sa room kwarto mo, sa bedroom mo. So, kailangan exhaust mo yan. Kahit may butas yung CR mo, di ba? May grills, may rubber. Doon ang intake ng hangin palabas doon sa exhaust ng CR. For comfort air conditioning system, the recommended pressure differential between the indoor and outer air is 0.02 to 0.05 inch water gauge. Water gauge indicates the pressure at the bottom of top open water column. I-define na. Yan. Ito yung recommended 0.02 to 0.05 inch water. Pero hindi naman ito masyadong kinakonsider sa mga. Sa hospital, kinakonsider ito. Kasi maraming rooms. So may mga rooms na hindi pwedeng lumabas yung hangin. Kailangan negative pressure. Okay. Kaya meron siya doon supply, exhaust, supply, exhaust, supply, exhaust. Mas mataas. Tapos meron siyang mga measurement na tine-check yung pressure differential. Building characteristic. So to calculate space heat yan, the following information of building envelope is required from architect. A. Architectural plans, sections, elevation for estimating building dimension, area, volume. Normally, floor plan lang bibigyan. So, tanong mo lang sila kung anong height ng ceiling, floor to ceiling. Kung walang binigay, di nila alam, mag-meters ka lang. O 2.7, 2.8. Pag mga bahay bababa lang, 2.8 ang height. Tapos yung floor plan, so hingin mo yung floor plan. Siguraduhin na floor plan may bintana. May pinto, may bintana, kita yung bintana. Kasi minsan, bibigay sa yung electrical, pag bibigay sa yung electrical, tinatanggal yung mga bintana. Okay? So B, building orientation, north, south, east, west, northeast, southeast, southwest, northwest, etc. Location, etc. So kailangan mo yon sa kasi kadalasan nga lang binibigay sa atin, walang orientation. Swerte na lang kung meron. Kasi may iba, drawing lang ng iba, sketch lang, o kaya bibigay sa iyo floor plan na walang, meron, minsan nga wala pang dimension, pero hindi nga dimension yan. Kaya, natanggal kasi nilang iba. Tapos, orientation, pag wala silang may bigay na orientation, ang ina-assume ko na lang ay yung sa taas is north. Okay? Tingnan mo yung plano, sa taas nun, yung external, internal shading, ground reflectance, etc. So, pag detailed yung binigay sa iyo, may magkita ka doon ng mga overhang o may mga building na katabi. Yan. Ma-consider mo yon. Pag wala, so assume mo na ng bare. D. Material of construction for external wall, roofs, windows, door, internal walls, partition, ceiling, insulating materials, and thicknesses. External wall and roof colors. Select and or compute U values for walls, roof, windows, doors, partition, etc. Check if the structure is insulated and or exposed to high wind. Ito yung detail na. Kung binigay sa iyo yung architect construction ng wall nila, yan, magagamitin mo yon. Kung wala, o naghalog, wall lang makita mo, walang ginagawang materials, so assume mo na lang yung nakahalog blocks. So, pwede ka na mag-set up ng U value doon. So, 0.25, 0.26 ang value, U value. BTU per hour per square foot. Yan ang ginagamit kasi walang mga silang maibigay. Okay? And roof, and then, so window, the sun, single glass lang. Assume mo, kung walang binigay. At minsan nga, bibigay sa'yo floor plan, width lang. Minsan, may nakalagay naman yung mga schedule ng window, tinan mo doon kasi may mga coding yan. W1, tinan mo W1, may gano'n din. Kunin mo yung area ng glass. Okay. Amount of glass type and shadings on windows. Next, operating schedule. Obtain the schedule of occupants, lighting, equipment, appliances, and processes that contribute to the internal loads and determine whether air conditioning equipment will be operated continuously or intermittently, such as shutdown during off period, night shutback, and weekend status. Gather the following information. A. Lighting requirements, type of lighting fixtures. Appliance requirements such as computer, printer, fax machines, water coolers, refrigerators, microwave, miscellaneous electrical panels, cable, etc. Utilities by the HVAC equipment. A number of occupants, time of building occupancy, and type of building occupancy. Yan. Lahat yan, hindi binibigay. Kung may binigay, gamitin mo. Pag wala, sa appliances, tingin ka dun sa table sa ASTE. Meron din mga ibang libro, meron doon sa internet, meron doon mga appliance heat load, yung mga load niya, BTU per hour. Okay? Utilized by HVAC equipment, yung fan, kung dadaan na siya ng hangin, meron na. So, makukompute mo yun. Number of occupancy ba yung, yan, meron mga occupancy table sa building code, sa ibang reference libro, meron ka makikita doon. Anong type? Office, hospital, meron doon square area per occupants. Okay. Pwede mo gamitin yun as approximate or tingin ka doon sa interior design. Bilangin mo yung restaurant. Bilangin mo yung upuan kasi yun yung number of tao. Huwag yung mesa. Okay. Plus, kung Jollibee, bilangin mo yung upuan na kaupo plus yung nakapila. Estimated mo. Okay. Sa Jollibee, sa mga kanyang McDo, hindi lang mesa ang bibilangin mo. Yung crew plus yung pila. Okay, now for the assumptions. Natakpan lang, natakpan. Okay. Cooling load methodology, considerations, and assumptions. The design cooling load takes into account all the load experienced by a building under a specific set of assumed conditions. The assumptions behind design cooling laws are as follows. A. Weather conditions are selected from long-term statistical database. The conditions will not necessarily represent any actual year, but are representative of the location of the building. Yung pinakamalapit. ASRE has tabulated such data. Okay. B. The solar loads on the building are assumed to be those that which occur on a clear day and a month chosen for the location. Clearly, kung may consider yung mga clouds, yung mga mahabugay ganitong ano, kasi hindi naman lagi yun. Clearly ang ano mo. See, the building occupancy is assumed to be at full design capacity. Yan. Okay. Assumed to be. Kung hindi po, pero alangan naman, hindi man pwede mag-record ka na. Mag-estimate ka na umaga, 10, alas 8, 10, alas 9, 15, alas 20. Hindi pwede yun. Dapat at full capacity. D, the ventilation rates are assumed on air changes or based on maximum occupancy expected. Kasi ang ventilation rate, merong air changes per hour, merong per person. Yeah, or air changes and in minutes nakalagay. May makita ang mga table no. E, all building equipment and appliances are considered to be operating at a reasonably representative capacity. F, light and appliances are assumed to be operating as expected for a typical day of design occupancy. G, latent as well as sensible loads are considered. H, heat flow is analyzed assuming high dynamic conditions, which means that heat storage in building envelope and interior materials is considered. Yan, kasi depende sa time yan. Merong time na malaki, yun ang pinatawag natin peak. Alas 3, alas 2 ng hapon. Yan, mataas yung cooling load niya. I, the latent heat gain is assumed to become cooling instantly, whereas the sensible heat gain is partially delayed depending on the characteristic of conditioned space. According to ASTE regulation, the sensible heat gain from people is assumed 30% convection, instant cooling load, and 70% additive delayed portion. J, peak load calculation evaluate the maximum load to size and select the reproducing equipment. The energy analysis program compares the total energy used in a certain period with various alternatives in order to determine the optimum one. Yeah. Okay, the space or zone cooling load is used to calculate the supply volume flow rate and to determine the size of the air system, the terminal, and diffuser. Centralized, isang zone. The coil load is used to determine the size of the cooling coil and refrigeration system. The space cooling load is a component of the cooling coil load. Okay? Kasi yung isa niyang component niya is the ventilation load. L, the heat transfer due yan. Due to ventilation is not a load on the building but a load on the system. Okay? Thermal zoning. So thermal zoning is a method of designing and controlling the HVAC system so that occupied areas can be maintained at a different temperature than unoccupied areas using independent set-top thermostat. A zone is defined as a space or group of spaces and a building having similar heating and cooling requirement throughout its occupied area so that comfort conditions may be controlled by a single thermostat. Sa example natin, tawag ng thermal zone. Okay? O sample 1. Sample 2 is yung same lahat yung conditions na isang room. Meron kasing room na malaki siya, parang mga function room, malaki, sa mga puro salamin sa wall. So, i-consider mo na mas malamig sa wall kaysa dun sa gitna. Pero sa atin, hindi naman ka consider yun. Pero dapat ganun. Kasi design mo yun, okay. Pero pagdating ng unit, ilalagay ko sa isang lugar daw, ganun din. Dapat, pati yung unit mo, distributed din yung cooling niya. Hindi lang sa computation. Diba? Kasi maganda, bakit meron pang perimeter cooling niya? Ako na perimeter cooling. Papaalis siya. Baka pwede naman ganito. Malalamig naman yan. Approve naman ng approving body. So, okay. Tayo magagawa doon. So, the right is para maging uniform ang lamig mo. So, kailangan mo talaga ng ganun. I-distribute mo yung unit mo. Atin din nangyari yan. Hindi nga sa mga contractor, ina-approve naman. Yan. When doing the cooling load calculation, always divide the building into zone. Always estimate the building peak load and individual zones airflow rate. The building peak load is used for sizing the refrigeration capacity, and the individual zone loads are helpful in estimating the airflow rate, air handling unit capacity. So, isa pa pala dito sa ano. Yan, pag ducted ka, maganda itong zoning kasi sa iba, i-damper mo, diba? Yung mga diffuser mo, sa may papaikot, yung mga nakatapat dun sa may salamin, ano yung sobrang init, mas malakas yung buga kaysa dun sa gitna na hindi na matatamaan ng araw. Eh, pero ganun nga, pagdating sa installation na, di naman na, minsan di naman nababalance, tawag doon, air balancing. So, pag air balancing naman, gagawin naman nila, ipapare-parehas nila yan. Hindi nasusunod. Pagdating sa'yo, has-built na, nakakabit na. In practice, the corner rooms and the perimetric spaces of the building have variation in load as compared to the interior core area. Sasabi sa'yo. The following facts may be noted. So the buildings are usually divided into two major zones. The exterior zone is the area inward from the outside wall, usually 12 to 18 feet from the wall if rooms do not line the outside wall. The exterior zone is directly affected by outdoor conditions during summer and winter. Interior zone, the area contained by the external zone. The interior zone is only slightly affected by outdoor conditions and usually has a uniform cooling. So, sabihin na. Exterior zone, ito yung mga zone na nasa walls na tatamaan ng araw. Interior zones, ito yung sa gitna. Okay? Wala siyang wall na tinatawag, exposed wall. A, sa single zone model shall be limited to open floor plans with perimeter walls not exceeding 40 feet in length. For large building footprints, ibig sabihin yung plano, floor plan, assume a minimum of 5 zones per floor. Pag malaki, pag maliit, wag na. 1 zone for each exposure, north, south, east, and west, and an interior zone. Yan, 5. Mamaya, example natin. Ito yung tamang pag-cooling down. Because since sa atin, minsan iba basa, sinashortcut na lang. Isa lang siya. Cooling down, isa lang. Tapos na. Lalagyan ng mga package units. Pero pag ducted, mag-ingat. Gawin nyo kung gusto nyo uniform, mabusisi yung designer na counterpart mo. At least, alam mo na yung hindi na hinahati sa 5 zone nyo. Ito, hindi ito magagawa na uwihira. Kung may software na gagawa ito. Anong manual to manual? Sa software kasi, isahan lang yan. Kung gusto mo, hati-hatiin mo. Ayan. Okay, as mentioned before, the heat gain to the building is not converted to cooling down instantaneously. CLTD or cooling load temperature difference, ECL, solar cooling load factor, and CLF, cooling load factor, all include the effect of 1, time lag in conducting heat gain, 2, opaque exterior surfaces, and 2, time delay by thermal storage in converting radiant heat gain to cooling load. So, kasama na yan. This approach allows cooling load to be calculated manually by use of simple multiplication factors. A. CLTD is a theoretical temperature difference that accounts for the combined effect of inside and outside air temperature difference, daily temperature range, solar radiation, and heat storage in the construction assembly building mass. It is affected by orientation, tilt, month, day, hour, latitude, etc. CLTD factors are used for adjustment to conductive heat gains from walls, roofs, floor and mass. So, about ito mga building mass, check na lang sa, sa books. Sa air conditioning course discussion. Pag course na, ito subject. Topic pa nga. Okay. External cooling load. As discussed before, the total cooling load on a building consists of external as well as internal load. The external load consists of heat transfer by conduction through the building walls, roof, floor, doors, etc. Heat transfer by radiation through penetration such as windows and skylight. All these are sensible heat transfer. Roof. The basic conduction equation for heat in is Q is equal to A delta T, where Q is equal to heat gain in BTU per hour, U is thermal transmittance for roof, and BTU per hour square foot Fahrenheit. A is the area of roof in square feet, delta T, temperature difference, and degrees Fahrenheit. So the heat gain is converted to cooling load using the room transfer function. Soil air temperature for rooms with light, medium, and heavy thermal characteristic. The equation is modified as U is equal to U as 3 times A times C and T D, where Q is the cooling load, U is the coefficient of heat transfer, roof or wall or glass, BTU per hour per foot Fahrenheit, A is the area of roof, square feet. CLTD is the cooling load temperature difference, degree Fahrenheit. The values are determined from table available in chapter 28 of ASLE Fundamentals Handbook. Later, mapakita ko design ninyo. ASLE 1997 to. Baliktad pa. Since the ASLE table provide early CLTD values for one typical set of conditions, that is outdoor maximum temperature of 95 Fahrenheit with mean temperature of 85 degrees Fahrenheit to. So, ayan. 85 Fahrenheit in daily range of 21 Fahrenheit. The equation is further adjusted to apply correction factors for conditions other than the mentioned case above. So, ibig sabihin, yung table na yon dito yung base, yung temperature. Tapos meron ka mga, then magkukorek ka na lang. The Q roof is UA CLTD roof corrected. So, ito yung typical. Ito na yung ano. The typical step to calculate the roof load are as follows. Step number 1, determine the roof construction and overall heat transfer coefficient U as 1997 chapter 24, table 4, and chapter 29, table 5. So, pinakita ko sa inyo Ashley, di ba? Yung 1997 IP edition sa English. So, hanapin nyo lang doon, chapter 29, chapter 24. So, step number 2, select group number from ASLE 97, chapter 28, table 31, which is closest to matching actual group construction. Nakikita mong malapit. Select number 3, step number 3, select CLTD roof for time of interest, typically on an hourly basis. ASLE 97, chapter 28, table 30. Step number 4, corrections. Values on tables are 4A. For latitudes on July or August. B. Outdoor maximum temperature of 95 Fahrenheit with mean daily temperature of 85 Fahrenheit and daily range of 21 Fahrenheit. So CLTD roof corrected is CLTD roof plus 78 minus TR plus TM minus 85. Okay. Where 78 minus TR is the indoor design temperature correction, TM minus 85 is the outdoor design temperature condition, TR is the indoor room temperature, T sub M is the mean outdoor temperature, T sub maximum is the maximum outdoor temperature. Tm is equal to T max minus daily range over 2. Kita nyo sa table naman. Step number 5, calculate roof area from architectural plan. Roof area inside ng building. And inside. Ang sukol mo sa top, di ba? Yung wall ng room ang susukatin mo. Ibig sabihin roof area, yung roof area ang buo. Kung ano pinag-consider ng room, yung nakatapat ng sa roof, yun ang buo. Ah, hindi projected, kundi yung actual. So Q roof is equal to UA CLTD roof, correct? What is soil air temperature? So the soil air temperature is a fictitious number that defines the value of outside air temperature, which would, in the absence of all radiation exchanges, give the same rate of flow Q in the outer surface of the wall as the actual combination of temperature difference and radiation exchange. So, yung table 28, tsaka na yan, mamaya. Kasi maraming table doon, papakita sa inyo ginamit natin. Babanggitin din dito. Check nyo na lang. So, para pa nagawa kayo, practicean nyo kung paano sa sample, paano na kinuha doon yung mga value. Yun ang pag-aaral, tamang study. Hindi yung panood na, makinig lang, uwi na, tulog na. Hindi naririnig lang walang back reading. Hindi naintindihan, hindi tinulugan na. Okay? Kaya yung mga example, aralan nyo rin kung paano yung kinuha. Diba? Kasi yun nangyayari lagi. Yung bigyan example, bago mo yung given, ibigay mo sa pagawa mo, hindi na. Balik na. Kaya hindi alam kasi hindi pinag-aralan kung paano. Or, yung example, pagdating ng exam, yun ang binigay mo, hindi yan nakuha. So, si zero pa rin kasi example na nga, zero pa. Same na nga yung given, same problem. Sabihin, hindi pure. So, the soil air temperature represents the equivalent outdoor design air temperature that combines convection to the outside air. Radiation to the ground and the sky, and the solar radiation will transfer effect on the outer surface of the building. It takes into account the mass of the wall or roof and the daily temperature range which affect the heat storage, the color of the outside surface which affect solar heat absorption rate, and the latitude of Earth. When the soil air data is combined with inside the cell temperature, the cooling load temperature difference is obtained. So the early soil air temperature values are presented in tables for various orientation of a surface for July 21 at 40 degrees north latitude. So with the standard surface absorption factor for light and dark colored surfaces in the handbook of fundamentals. Yeah. As per 1987, the soil air temperature are listed for a given air temperature cycle. Adjustment can be introduced for other dates, latitudes, and air temperature cycle. When this method is used in conjunction with custom table generated by appropriate computer software, and for buildings where external shading is not significant, it can be expected that it will produce the result very close to that produced by the TFM, transfer function method. For a complete discussion of this concept, refer to us the handbook. Walls. The cooling load from walls is treated in similar ways as roof. Q wall is equal to UA CLTD wall corrected, where Q wall is the load to the walls in meter per hour. U is the Tillman transmittance per wall in meter per hour per square foot Fahrenheit. A is the area of walls in square foot. CLTD is the cooling load temperature difference per walls in Fahrenheit. The typical step to calculate the wall load are as follows. Step number 1. Determine the wall construction and overall heat transfer coefficient U as to 1997, chapter 24, table 4, and chapter 29, table 5. Dalawa to. Sa kasi dito is ito is glass. So step number 2, select wall type from as 1997, chapter 28, table 33, which is closest to matching actual wall construction. Pay attention to the effect of mass distribution, inside isolation, outside isolation of evenly distributed. Step number 3, select CLTD wall for the time of interest, typically on hourly basis, as 1997, chapter 28, table 32, chapter 28, table 34. Step number 4 is correction. Values of tables are for latitude on July or August, B indoor temperature, of 78 degrees Fahrenheit. C, outside outdoor maximum temperature of 95 Fahrenheit with